2026 A-Level Combined Mathematics Paper 1 Part B Question number 15 Part C. Parts A and B of the same question were discussed in previous videos, links in top right. Part C of this question has to do with a little bit of trigonometry and integration. The question starts off by saying, show that cotangent of 3 pi by 4 minus x is equal to 1 minus cotangent of x divided by 1 plus cotangent of x. The question then says, using the formula integral from a to b of f of x dx equals the integral from a to b of f of a plus b minus x dx, where a and b are constants, show that the integral from pi by 4 up to pi by 2 of the natural logarithm of 1 plus cotangent of x dx is equal to pi by 8 times the natural logarithm of 2. Now to start with this question, let's write down this expression of cotangent of 3 pi by 4 minus x and try to simplify it down to this expression right here. So to start off, what I'm going to do is to substitute in the cotangent as being equal to the cosine divided by the sine. So I'm going to write here cotangent of 3 pi by 4 minus x being equal to cosine of 3 pi by 4 minus x divided by the sine of 3 pi by 4 minus x. Now into here, what I'm going to do next is substitute in the formulae for cosine of a minus b and sine of a minus b. Now the cosine of a minus b is equal to cos a cos b plus sine a sine b. And therefore, if we have the cosine of 3 pi by 4 minus x, it can be written as cosine of 3 pi by 4 times the cosine of x plus the sine of 3 pi by 4 times the sine of x. Now similarly, on the denominator, we have sine of 3 pi by 4 minus x, which can be written as sine of 3 pi by 4 times the cosine of x minus the cosine of 3 pi by 4 times the sine of x, as sine of a minus b is equal to sine a cos b minus cos a sine b. So now we have this. Now what I'm going to do next is to substitute in cosine of 3 pi by 4 and sine of 3 pi by 4. Now as we know, the cosine of 3 pi by 4 is equal to negative 1 over root 2 and the sine of 3 pi by 4 is equal to 1 over root 2. So substituting those two in, we can see we have negative 1 over root 2 times the cosine of x plus 1 over root 2 times the sine of x divided by 1 over root 2 times the cosine of x, and then you have minus, but then you have minus 1 over root 2 as cosine of 3 pi by 4 times the sine of x. Now if we divide everything by 1 over root 2, we can see on the numerator we get minus cosine of x plus sine of x, which I'll write as sine of x minus cosine of x, and on the denominator we get cosine of x minus negative sine of x, which is plus sine of x, which I'll write as sine of x plus cosine of x. Now the final step to do here is to divide everything by sine of x. So doing so, we can see we get on top just 1 minus cosine of x divided by sine of x, which is the cotangent of x, and in the numerator that's what we get, and in the denominator we get sine of x divided by sine of x, which is 1 plus cosine of x divided by sine of x, which is cotangent of x. So therefore we can see we finally get the form we were looking for of 1 minus cot x divided by 1 plus cot x. So as a final statement, we can say therefore cotangent of 3 pi by 4 minus x is equal to 1 minus cot x divided by 1 plus cot x. Now after that, the question then says, using the formula integral from a to b of f of x dx equals integral from a to b of f of a plus b minus x dx, where a and b are constants, show that this integral is equal to this value. Now in the integral, we can see the integral has an a and a b and a function, and therefore we can substitute in this formula into the integral, and therefore I can write this integral, which is the integral from pi by 4 to pi by 2 of natural logarithm of 1 plus cotangent of x dx, integral from pi by 4 to pi by 2 of natural logarithm of 1 plus cotangent of x dx. I can write it using the formula here as integral from a to b of f of a plus b minus x. So instead of f of x or x's here, I can substitute in a plus b minus x, and here a and b are pi by 4 and pi by 2 respectively. So there we can see instead of x here, I can substitute in the integral from pi by 4 to pi by 2 of the natural logarithm of 1 plus cotangent, and instead of x I can substitute a, which is pi by 4, plus b, which is pi by 2, minus x dx. So we get this expression right here for this integral. Now to solve this integral, what I'm going to do is to call this I and take a look at what this side simplifies down to. So we can see this side simplifies down to the integral from pi by 4 to pi by 2 of the natural logarithm of 1 plus, and on the inside we have cotangent of this angle, which is pi by 4 plus pi by 2, which is going to be equal to pi by 4 plus 2 pi by 4, or 3 pi by 4 minus x. Now you should immediately see that we have the expression that we solved for in the first part of the question. We have cotangent of 3 pi by 4 minus x. And the reason they do this is because when you solve for this separately, you can easily see a substitution and it will be much easier to actually solve the problem. If they instead just gave you this part from the start, you would not be able to easily find that you can substitute in cotangent of 3 pi by 4 minus x as this value right here. So in these questions, they give you this first to solve, and after that, you can see the substitution you have to do using this. So what I'm going to do here is to use this equation right here, which I'm going to call equation A, and substitute it into this integral right here. Now substituting it in, we can see from integral A, or the equation A, we get that the integral I is equal to the integral from pi by 4 to pi by 2 of the natural logarithm of 1 plus, and instead of this we can substitute 1 minus cot x divided by 1 plus cot x. So doing so, we can see we get plus 1 minus cot x divided by 1 plus cot x integrated with respect to x, and we can see if we take this under a common denominator, we will get the integral from pi by 4 to pi by 2 of the natural logarithm of, and here we have 1 plus cot x plus 1 minus cot x divided by the common denominator of 1 plus cot x. So we have this. Now here we can see the plus cot x and minus cot x will cancel out, and they leave us with 1 plus 1 as the numerator, which will lead to the integral from pi by 4 to pi by 2 of the natural logarithm of 2 divided by 1 plus cotangent of x dx. Now at this point, we have to be a little bit clever. We have to realize that over here we have the natural logarithm of 2 divided by 1 plus cot x as the integral I. And back here we had the integral I being equal to that same limits of natural logarithm of 1 plus cot x. So here we can see we have 1 plus cot x on the numerator, but here we have 1 plus cot x on the denominator. We need to also realize that if you have the logarithm of a and you add to that logarithm of 1 over b, this is going to be equal to the logarithm of a times 1 over b, which is equal to a over b. Now using these two facts, if we consider what we can do here, if we add this integral to this integral, then on the inside of the integral signs, we'd have natural logarithm of 1 plus cot x plus the natural logarithm of 2 divided by 1 plus cot x, which would lead us to these two being cancelled out, because if you add these two together, we're going to get the natural logarithm of 2 on top and 1 plus cot x on top divided by 1 plus cot x, and these two will simply cancel out, leaving us with a constant of natural logarithm of 2, and therefore the integral will be very easy to solve. So due to that, we have to have a little bit of pattern recognition and realize we are supposed to take this value of I right here, this equation for I, and this previous equation for I, and add them together to get things to cancel out. So what we're going to do here is to say therefore 2 times I is equal to I plus I, and for the first I, we're going to substitute this integral right here, which is the integral from pi by 4 to pi by 2 of the natural logarithm of 1 plus cot x, and to that we're going to add the second I, which in this case of this I, I'm going to substitute in this second expression for the integral I, which is the integral from pi by 4 to pi by 2 of the natural logarithm of 2 divided by 1 plus cotangent of x with respect to x. And adding these two integrals, we can see, since they have the same limits, we can take them under the same integral sign and write this as being equal to the integral from pi by 4 to pi by 2 of the natural logarithm of 1 plus cot x plus the natural logarithm of 2 divided by 1 plus cot x integrated with respect to x. And finally, we can add these two logarithms using logarithm rules and write this as the integral from pi by 4 to pi by 2 of the natural logarithm of 2 times 1 plus cot x divided by 1 plus cot x integrate with respect to x, and we can cancel these two and leave us with the integral from pi by 4 to pi by 2 of the natural logarithm of what's left on the inside, which is just a 2. So natural logarithm of 2, which is a constant. And with that we can see this integral is simply going to be equal to x times the natural logarithm of 2 integrated with the limits of pi by 4 and pi by 2. Now substituting in the limits, we can see we have pi by 2 times natural logarithm of 2 minus pi by 4 times natural logarithm of 2, which is going to be equal to pi by 4 times the natural logarithm of 2. Now this is equal to 2 times I. So double the integral we want, 2 times I is equal to pi by 4 times natural logarithm of 2, and therefore if we divide by 2, we get I being equal to pi divided by 4 divided by 2 or pi divided by 8 times the natural logarithm of 2. Hence the integral I, which is this integral right here that we wanted to find, the integral from pi by 4 to pi by 2 of the natural logarithm of 1 plus cotangent of x integrated with respect to x is equal to pi by 8 times the natural logarithm of 2. And with that, we are done with this question. Now finally, let's go up and discuss the marks awarded for this question. So at the start of the question, when you take the cotangent, write as cosine divided by sine and substitute in the formula for cosine of a minus b and sine of a minus b like so, and do it correctly, for all of this, you get 10 marks. Now after that, when you substitute in cosine of 3 pi by 4 and sine of 3 pi by 4 and simplify down and eventually get the formula that they asked for, you get another 5 marks. Now after that, in the next part, when you do integration, for substituting into the formula that they gave you like so and getting the integral from pi by 4 to pi by 2 of the natural logarithm of 1 plus the cotangent of pi by 4 plus pi by 2 minus x, you get another 5 marks. After that, when you get the cotangent of 3 pi by 4 minus x and substitute in the equation that we found in the first part like this, for substituting it incorrectly, you get another 5 marks. Now after that, when you simplify down, when you cancel out these cotangents and get this value right here of 2 divided by 1 plus cotangent of x, and then you take this integral form of I and this other integral form of I and add them together, for adding them together like this, you get 5 marks. Now after that, when you simplify down, cancel out using natural logarithm terms, and then you get x times natural logarithm of 2 evaluated from pi by 4 to pi by 2, and then you get I equals pi by 8 times natural logarithm of 2 as your final answer. For writing this down, you get a final 5 marks. And that is the end of this question. So I hope you enjoyed. If you have any feedback or questions, post them in the comments down below. Thank you for watching, and goodbye.